Hi guys, welcome to my lesson. Guys, let's look at this question and see whether we can be able to solve it. So guys, welcome so much and let's start our lesson. I read the question. Table 1 represents the frequency distribution of length of 150 components in centimeters, cut off by an automatic guillotine machine. Determine the first question is mode, then you have the interquartile range, and lastly we have quartile deviation. So guys, we want to start with the mode. For the mode, guys, it's going to be the class. First of all, we identify the model class, and the model class is the class with the highest frequency. So according to us, the highest frequency here is 45. So guys, we find that our model class is here. This is our model class. And therefore our mode is between 45 and 60. So first step, we identify the model class, which is this, the highest frequency. And then from the highest frequency, we identify the model class. Secondly, guys, we now come and look for the mode. And before we look for the mode, there are various parameters that the mode is measured with. One of them is L, and the L is the lower class. This is from the word L, lower class boundary or limit of the model class. That is the L. And then another parameter we identify is D. Let me call it D1. For D1, guys, this one is supposed to be the difference in frequency. Let me write it here. Difference in the frequency or between model class and the frequency of the class before the model class. So that's how I could define that. And then guys, we also have the D2. Let me write it down here for the D2, but we shall use those graphs. For the D2 is the difference in frequency of model class and the class after. And the frequency is the frequency of the next class And finally, guys, we have the class interval. We call it class interval. And this one is upper class limit minus lower class limit. Like that. So guys, that is the I. And now guys, for us to be able to understand that well, I'm going to use these two diagrams here. First of all, guys, let me just use this one that is here, because this one is what represents now our diagram, our table here. Here we have, first of all, we have the lower class limit of the model class. So the model class we have identified it is this. So the lower class limit is now going to be 45. 45 is the lower class limit, because you find that here we have 45 and 45. So there is no number in between. And so this is the lower class limit. So L, we identify it as 45. Then the D, the difference in frequency between the model and the frequency of the class before the model class is here. The frequencies, we are looking at the model class, that is the main focus. So this frequency 45 minus the frequency of the class before the model class, the difference is 45 minus 30. And then we have this other difference, the difference in frequency of the model class and the frequency of the next class. And the next class after that is this class with the frequency of 20. So the difference is now the D2. Now coming to the class interval. Class interval is the upper class limit minus the lower class limit, or upper class boundary minus the lower class boundary. For this, the lower class boundary is 0 and the upper class boundary is 15. So you minus that, you get 15. And so guys, after that, now here is our equation, and I still explain it to you using this diagram. But before I go to the equation, this is now what we have learned. We have said the lower class limit is at this point. Let's say this is our model class. The model class has lower class limit of 45. I'm using this diagram, guys, not this one, but this, because this is what represents what we are now doing. The lower class boundary is 45. Then we have the difference in frequency, that is D1, frequency of the model class, which is now 45. The frequency of the class before the model class is 30. So the difference now, what we are talking about now, guys, is this. This is the D1. Coming to D2, the difference in frequency of the model class, which is at this point, and the frequency of the next class. The frequency of the next class is supposed to now to be 20. So the difference we are talking about, guys, is this. This is our D2. And the class interval is from this point to that point, which now we have is 15. For us, is supposed to be 15. So this one, we can call it 15. That is 15. Now guys, I come now with the equation that we use. This is now the equation we use. And actually we can look at this diagram and see, because our mode, we said, is inside here. So we have to start with the 45. So I have to add 45. But now let me just write it in terms of the parameter. So it is going now to be L, the lower class limit, plus Now the fraction of this, that is d1 all over, in this, at this point, we have the d2. So we will have first of all the d1 there, all over, now the d1 plus d2. You can see that is a fraction. You multiply that by the class interval, like that. So guys, that is our formula. And for us to find the point here, where now our mode is, there are two things we can do. Let me now start with this diagram here. Assuming that we have something like this. We have maybe our class, the class after the model class, let's say it has 30, the frequency of 30, meaning that the D1 and the D2 are equal. What we now do, guys, is this. For us to be able, there is a method of approximation whereby a video a line from this point goes a diagonal up to that point, and another diagonal up to this point, like that. Guys, if we now come and now draw a line moving through where the diagonals have intersected, we will get our mode at that point. Meaning, guys, what we are now using, it's like we are using normal distribution. Though it's not normally distributed, this one, it's like, guys, if I were to maybe produce that line up to that point, so you can see, guys, it's like there is a curve that touches maybe at this point. Let me say at this point, it's like a curve that moves like that, and then comes again to this point. And so, guys, what happens is that the more we have, if this one now is higher, it means that this point will be more on this side, meaning that more student, or the components, we are talking of components, more components will be on this side. If this one is higher, meaning that we now come from this point, we produce a diagonal here, this center will be more on this side, meaning that more of the component will be on this side. But now, according to this, the components are evenly distributed this side and this side. So meaning at the center is where you have our mode. But now, guys, look at this. For this one, you can see that there are more components on this side than on this side. So it means our mode will now not be at the center. It will be more on this side. Meaning that if our midpoint is at this one, we have 45. We have, this is the midpoint here is supposed to be between 45 and 60. This 45 we have here is the frequency, but the frequency, this is the frequency, and this is the lower class boundary. And then the upper class boundary we have here is 60. So here we have, I would say we have 45 plus 60. And so 45 plus 60 equals to 105 divided by 2 equals to 52.5. So guys, if our graph would have been like this, then we would have had our mode as 52.5. But now, guys, we are saying our mode then, because this class has more components, it means that there will be more components toward this class than towards this class. And so, guys, let's see. So we now come and input our figures here. Mode is equals to the lower class limit is 45 plus the first difference is 45 minus 30, and that is 15. And then we have here 15. And then here we have the second difference, D2, which is now 45 minus 20. And that is 25. And then you multiply by the class interval. For the class interval, we have seen it's supposed to be 15. So guys, that is what we get. So here we shall have 45, then plus, guys, if we work out this one, our solution will be 0.375. I've already worked out. Then here we have 15. And then from there, guys, we will have 45. Here we shall have 45 plus this one now is going to be 5.625. And finally, guys, our solution then is going to be 45 plus that, it will be 50.625. And so guys, you can see what I was talking about. So I was saying, guys, that now that this class has a bigger frequency than this, our mode then will be towards that point. And this one is what now provides the fraction for that. The D1 all over D1 plus D2. For this, guys, if we come to this one would have been a half D1 over D1 plus D2, because this one would have been 15 all over 15 and then another 15, that is 15 over 30. If you multiply that 15 over 30 times 15, you'll find that, let's multiply that. We now look for this, the mode for this guys. So we shall have, first we have 45, then we have 15 divided by 30 is equals to times what we call 15 again. So we get 7.5. So guys, we add 7.5 to 45, and that gives us 52.5. So guys, I believe you have well understood. Yes, have you understood? I hope so. Guys, thank you for listening to me. But now, guys, we are still not done on interquartile range and quartile deviation. So guys, please follow me in the next video where I'll be tackling interquartile range and the quartile deviation. Bye bye.